So I was initially down on the lessons learned section as well. So this is another one of these lessons learned kind of data talks. And I kind of gave it a subtitle, paraphrasing a dead random. I picked one example of a nice project that people can kind of learn lessons from. This put it here is Daphnia. It was a nice high-profile paper that was published at the beginning of the year in Science. Really nice, got nice press coverage because it's got this really small genome, but more genes than the human does, and it's really proven itself as a really nice kind of eco-responsive model. What people didn't really pick up on so much, though, was the consortium did an excellent job. They released their data about 4 years ago, and in that time, there have been about at least 58 companion papers published. And so it's a really nice example of, they shared the data early, it really helped the community over this period of time. There's now about 500 registered people in the consortium, and it didn't prevent a really nice science paper being published at the end of it. So it's a really nice example there of sharing the data, but it also demonstrates that it took, this isn't a massive genome, it took about 4 years to get the paper out, and a lot of coordination was done behind the scenes. The papers were published in groups, and so with all these new mega sequencing consortia, these 1K, 10K projects, it's going to get harder and harder to really try and coordinate these things in the future. Talking again, a lot of these things have come up in the other talks, and so have a lot of the slides. I think there's a Moore's Law drinking game for genomics conferences, so people can drink now. But it's it's this classic issue. Sequencing output is rocketing, and people really don't know how. People have, picked up on the issues with storage and handling, but what people haven't picked up on so much is the dissemination aspect. And if publication is the ultimate way that people release data and make this stuff available, this process hasn't really changed much in the last 400 years. There have been things like open access and more stuff is going into databases, but BGI kind of tasked us a bit to at least try and think about these issues and maybe streamline the process or optimize it for kind of big data projects that BGI and other people are currently doing. And it's very clear, at the BGI we've got crazy numbers of high-seqs we're churning, and we have the potential to churn out vast amounts of data. With the new upgrades that we've got on the high-seqs, theoretically we can churn out up to possibly 2,000 human genomes a day, which is gem bank amounts of data in very short periods of time. So there's no, we have to be partially responsible for the issues with SRA not being able to kind of take this data now, even though they've had a bit of a reprieve. The sort of long-term consequences are still not clear. So another issue that people have raised as well for large data, for these new basically for data producers, are that people have asked, and there are sort of forms of credit for producing this data. It needs to be more easily accessed and kind of cited. People have been talking about this for years, and it's great that this has actually become a reality now with this DataSite consortium. There are a group of librarians, and they're working now with data producers, and they've made these special data DOIs really tailored for data producers. It's much cheaper than the old system of DOIs, and it's really feasible to work this into new generations of databases. So, and the really interesting thing in this month or next month, their metadata repository is going live, and so it'll make finding data sets a lot easier. And the really interesting thing is that they are tying it in with Thomson ISI and Web of Science. So the consequence of this are finally we'll be able to track and credit data use. You'll be able to get metrics for how many exactly which people are using your data sets, which is great for data producers. And if people want to go down that road, you could even make data H in the indices and even like a data impact factor. So with all of this stuff going on. We've BGI, and in conjunction with Biomed Central, putting together this large-scale data journal and database. And so it's going to be open access, and we really want to make it a kind of home for the sort of data, large data and open data community. These are the kind of things we really want to focus on. We really want to optimize it for the issues handling large data, and not just omics data. There's so many fields now that are producing these large data sets, and they might not have repositories out there. And so we want to be like a forum for discussion about this. And to date, most journals have really focused on this kind of. We want people to use BGI's data, use data in the database, and peer review process is mostly concentrated on this sort of first part, and it's quite hard to get it right, really. We're not going to totally ignore this, but we really want to look at the second. For data sets, we really want to look at the second side, and it's a lot easier to judge if people have been doing these things. So this is going to be our main focus in the peer review process. We really want to give credit to these sorts of issues, and we're very fortunate at the BGI. We've got petabytes of storage space here. We have the BGI cloud, and we want to integrate all of this with the journal. If people have tools that they would like us to peer review for handling data in the cloud, we can use BGI Cloud as a test environment. The BGI Cloud are building up integrated tools that will allow people to play around with these large data sets. And there's lots of great things now like Galaxy. We really encourage authors to use these kind of workflow systems. Instead of a method section, somebody could just submit a Galaxy XML file. It'll just be basically a link as the methods, and the experiment will be completely reproducible. Things like that we want to give extra credit to. Yes, we want people to be able to find the data and use the data. So we're working with communities such as ISA-TAB. We're making our database compatible with this, and we're integrating the tools to help the kind of review and curation process. We're also going to employ curators to, this is a bit of work, so we're going to work with the authors to do these things. Because we have petabytes of storage space, people don't really have the excuse anymore that there's nowhere to put their data. So we're really pushing for open data. We're really pushing for people to use, if there are checklists out there, put those in the methods, and we're part of the by-sharing network now, and our instructions for authors are linking out to all of their lists of standards and the like. So, and we've been working with the British Library on this data DOI, data publishing site, so we can publish the large data sets that we are publishing alongside articles. We'll give those DOIs, so they'll be searchable in this new metadata database, and we're also pushing to get a lot of BGI's data sets available in this way. And if there are large projects such as the EMP, if they're interested in getting DOIs, we can either help put them in touch with data site members, or eventually we might even become a data site, a DOI issuing body ourselves. And if there's a suitable kind of citable object that you're likely to get out of a project such as this, it can be very cheap to build these into your sort of data dissemination pipelines. So I thought I would finish with just on a nice note. This is the first DOI that we've issued this week, number one, and so we're also in the next couple of weeks starting to release some of the genome 10K vertebrate genomes in this way. And it's just, I thought this is just a really nice example of new ways that science can be done. We've had a great response. People have called it the Tweenome, the sort of crowdsourcing of E. coli. And we put the data on Twitter before it even finished uploading to NCBI, and fortunately there was a conference in Cambridge at the time, a big microbiology conference. They all started analysing this data within 24 hours. There were assemblies and annotations out there. After a couple of days, there was a GitHub repository. All of these guys, there's at least 20 groups now have all submitted data to this repository, and it's been about a week and a half. So it's just there are different ways of disseminating data and sort of engaging the community. So I hope it's useful for the EMP to think about these things. So I'd like to say thank you, and anyone else has any questions, or if you have any data sets or data heavy articles you'd like publishing, come and talk to me.
Thank you very much. Other question? Eric, you would like? Okay, in that case, since we're a bit behind anyway, let's move on to the next speaker. Next speaker is